The Rise of Three-Dimensional Printing by Jessica Helminiak. Welcome! Today I am eager to present to you the groundbreaking impacts that the 3D modeling world has to offer. This is also known as 3D making and 3D printing. Table of Contents. This table of contents outlines exactly what I will be providing with you. What 3D printing is, its historical uprising, what 3D modeling is up to today, the competitive fields, social issues it presents, and why I am so passionate in 3D systems. A 3D printer and CAD design software work together to create a print of the user's choice. A CAD program is conducted on a strong running computer and also allows a user to produce a 3D model of any shape, size, or material. 3D CAD systems range from different producers, yet each serve a different purpose. Some designs programs have tools and operations that are geared towards more mechanical engineering, such as SolidWorks and AutoCAD. Other programs allow more graphical and artistic tools in Rhino and SketchUp. When their file is complete, the user may connect their CAD system to an external printer. This system then takes their model information and begins to sculpt the shape in plastic layer by layer. This process can take up to 10 hours or more. But in the end, your desired results are printed and complete. As there are many different programs available, more and more variations and users arise. This allows access and growth not towards only the engineer, but the artist, architect, medical physician, film animator, and user at home. The history. For most of our century, printers have created text and images on pieces of paper. We have now turned a 2D piece of paper into a 3D sculpture by machinery. In the United States, 1986, Chuck Hull produced the first stereolithographic model, in which a liquid is molded by UV light and dries into the desired shape. He founded his own company named 3D Systems, and soon became well known. Quickly, groups from other countries such as Italy and England became his competition, as the fight towards innovations in 3D printing continued to rise. Timeline. In 1986, Chuck Hull began his company of 3D Systems and created a large team and grew a larger audience. Between 1987 and 2009, patents for 3D Systems stereolithography devices were then passed. Items were created such as selective laser sintering, force feedback haptic device, color jet printing, multi-jet printing, VR virtual reality, surgery simulator, reverse engineering software, and on-demand parts manufacturing. In 2009, MakerBot began. Zach Krogan and Adam Meyer introduced MakerBot, in which scans an object and follows to replicate it faster than ever before. The discussion rose as to why 3D printing is needed, and whether it is safe to make anything you'd like. Throughout history, humans made items by hand, or by large machine. But 3D printing allows very customized, micro-detailed models that can't be made by hand. Also in 2009, users began making prosthetic arms and bones to make a large difference and outbreak in the medical world. But other users began to make pistols and weapons. Users have the right to make anything they want, as long as it is recognized as original or copywritten material. In 2011, Formlabs began. Formlabs was then introduced, which brought forth even more accurately detailed models and options. As these companies began to compete in price and abilities, they all remain innovating and release new systems today. Targeted audiences. 3D printing can provide innovation for multiple career paths and organizations, and possibilities are endless, which is how it will transform our society one day. These include health, engineering, sports, chemistry, and architecture. In health, as 2D images of human body parts are beneficial, such as the brain and the liver, a 3D model allows doctors to get an even better look at every detail. The object is now printed replica of the patient's body part, so it can be examined more officially. Doctors can even practice operations on 3D prints. This practice will deduce errors that doctors can make on real patients. Cheap prosthetics. As some patients cannot afford an extremely expensive body part replacement, cheaper 3D prints can allow for cheaper replacement. Numerous bones can be inserted inexpensively and even be customized for certain body dimensions. To quickly decrease the time for new supplies to come into the hospital, even during COVID-19, a 3D printer can also rapidly print out what is needed while lives are in danger. This is such an efficient process that helps hospitals and many other organizations, such as engineering. As engineering is one of the first fields to develop 3D CAD softwares, it directly affects today's engineers. Different programs are already made that serve different engineers. For example, SolidWorks serves mechanical engineers, and AutoCAD serves civil, industrial, and design engineers. Each program has the same element of creating a model that you can print and rotate, but the functions and simulations will be different. These simulations provide even calculations of the physics for the item for you. This is incredible in terms of prototyping, and engineers test printed models all the time to show their ideas to teammates. It is a great tool, and so many engineers use it, and I frequently used it back in my subjects of my engineering courses. Sports. In sporting equipment, materials on a bike, for example, are lighter, cheaper, and quicker when printed. If a bike needed a customized hand grip or seat, the printer has got their back. Headgear even provides for safer helmets in football and baseball. Certain printed patterns can decrease the amount of force impact they may run into. This will heavily reduce the injuries that sportsmen will endure. One day this semester while rock climbing, I learned that each week the indoor rock climbing wall will be designed with new stones to climb. This is in order to keep their customers entertained each week. This could easily be done with colored 3D printing, as so many custom pieces will improve the sport immensely. I instantly thought that all of these pieces already looked like 3D printed pieces, and they definitely can in the future. This idea was introduced to the rock climbing community in 2017, and it's slowly being launched today. Chemistry. There is such a thing as microscopic printing, and it is out of this world. Printers in development will one day be able to monitor blood cells and molecules of a patient through 3D scanning. Prints can then be constructed microscopically to interact with the patient's bloodstream, and that is only the beginning. Imagine a world that will be able to scan so much of the body and print out an exact counter for that found outlying issue. Cancers and so many diseases could be cured. Even new chemicals could be created with microscopic printing. But that is only assuming that chemical engineers will go even further in pursuing 3D printing softwares and printers. Architecture. The opposite of microprinting is macroprinting. Believe it or not, there has been a 30-foot 3D printer that has printed out a wall for a building. Imagine how quick and cheap and sturdy a building could be if it could be 3D printed. Architects also adore making tiny floor models. And even using ArchiCAD, they can print out a prototype of their house design without the struggle of inserting incredibly small details hand by hand. This involves a mess of glue all over your hands trying to get little tiny pieces, such as furniture, tiny pieces of furniture, into tiny models. But printers could get your design very easily printed with details smaller than the human ability. Competition. One may argue that you can sculpt an object in clay quicker and cheaper than a couple $1,000s and 20 hours of printing time. But what makes 3D CAD systems and printing groundbreaking is its process of additive manufacturing. As plastic is formed and molded layer by layer, it can form into highly customized shapes that the human can never match in precision. Manufacturing factories are masters at creating items in rapid order. 3D printers can print with cheaper and more custom materials, though. Imagine a 3D printer that only used recyclable materials through its system nozzle. These shapes can be inserted into the body to fix a broken bone or inserted into cakes for gorgeous decoration. The possibilities are endless. Therefore, 3D printing will only become easier, cheaper, and more common as the years pass on. Social issues. The impact that 3D printing brings to society is many things, but mainly the takeaway of jobs. There are factories in the eastern area of the world that have factories with absolutely no lights or humans inside. It is only printers and robots who are getting the job done faster than ever before. This is called lights out manufacturing. The argument as to whether this is better for employees and society arises as workers can operate the robots, but others might get fired. The issue today that normal citizens deal with is how expensive printers and CAD programs are to own, and how long the printing process takes. Your average printer can cost from $200 to $800, in addition to the hefty CAD system licensing and printing filament. Sorry, not everyone is into this hobby, as it is not the cheapest, but even the ones who do have such hobby experience issues. Companies and users at home have to deal with long printing times and even errors in the print. Prints can take hours to days, and that is not a very attractive quality. And worst of all, once you are done waiting for the print, it may have an error or a malfunction in it. Not all technology is dependable, so this can ruin someone's hobby or manufacturing team. But why? Why should we use 3D printing then? This is socially argued that it is cheaper, environmentally friendly, quicker than the human hand, more durable, and flexible to 3D print something. My passion. These are examples of 3D models and prints I have made within my minor of digital fabrication. The reason 3D printing and CAD interests me is because I see it as an art form. I believe 3D systems are empowering and allow ideas from my head to be made digitally, whereas it would be harder for me to make them intricate pieces by hand. Creating an item in CAD is one of my favorite hobbies, especially when it is assigned and used for a purpose. For example, in one case, I created a femur, printed it, and sent it to an anatomy lab. That was one of my favorites, as I felt that I was actually making a difference. In my former engineering major, it was very useful in mechanical design and civil design, and within my minor of digital fabrication, it serves as a ceramic. And this proves that I have witnessed 3D systems in action in multiple fields of both calculating mathematics and creating artwork. I repeatedly mention that I deeply feel that 3D modeling allows the mind to produce products never seen before. As the system becomes more popular within different careers, it will easily become a necessity in multiple fields. Prints will eventually be able to speak to us, print out any food, let us customize engine part or human bones, or microprint cell-like membranes. The dream goal, as seen in futuristic movies, is to be able to press a machine button. Within minutes, a plate is printed in a cheeseburger or necklace. If 3D printing and CAD work to continue and innovate and progress, then our society will rise to incredible possibilities we haven't yet even thought of today. As said by CEO of 3D Systems, with 3D printing, complexity is free. The printer doesn't care if it makes the most rudimentary or complex shape, and that is completely turning design and manufacturing on its head as we know it. Thank you.